The scatter plot of a paired data is shown. Determine whether there is positive linear correlation, strong positive linear correlation, a perfect negative linear correlation, a strong negative linear correlation, or no linear correlation. So first of all, as we mentioned in the previous problem, that when the points seem to be always rising as a group, then that's positive correlation. And if they seem to be falling, then it's negative correlation. So over here, they fall for a while and then they start rising. So it has to be the same thing throughout. So if there's a combination of rise and fall, then it's no linear correlation. But let's look at the other ones as well. Perfect positive linear correlation will happen if the points are all on the same straight line. And a perfect negative linear correlation will happen if they're all on the same straight line. So I've said the same thing for both perfect positive and perfect negative. But if they're on a line of a positive slope, then it's perfect positive. And if they're on a line of a negative slope, then they're perfect negative. Now, strong positive linear correlation will be if the points seem to be rising and they're very close together. They don't all have to be on the same line, but they are clustered together pretty well. So if you just look at this part, if we just had this portion and nothing else, that seems to be a pretty strong positive linear correlation, because although they are not all on the same straight line, but they are pretty close together to each other. And same for strong negative. This portion seems to have a strong negative correlation, and yet it's not perfect negative because they're not all on the same straight line. Now, if the points were rising, but they are not clustered together as closely as like these are, then we'll still say it's positive correlation, but it wouldn't be a very strong one. The scatter diagram shows the relationship between average number of years of education and births per woman of childbearing age. Use the scatter plot to determine whether the statement is true or false. There's a strong positive correlation. No, there seems to be a negative correlation. Either it's a negative correlation, or you can say there's no correlation. It's a very weak kind of correlation either way, but definitely not positive, because the points don't seem to be rising. They're either falling or there's a fall and some rise. So in either case, there is no positive correlation. Okay, then we have explanatory variable and a response variable. Now, explanatory variable is very similar to the independent variable that you know of, and the response variable is like the dependent variable. So if a farmer wants to determine if the temperature received by similar crops can be used to predict the harvest of the crop, okay, so temperature is the independent variable and the resulting harvest is the dependent variable here. So we said that the explanatory variable is like the independent variable. So the explanatory variable here will be the temperature, and the response variable is like the dependent variable. So that's the harvest, because harvest is a result of the temperature. Correlation implies causation. Okay, statisticians love to say that this is false. Correlate just because two things are moving in the same direction doesn't mean that one is causing the other. So, for example, we may say that in a country where we have more computers, uh, the average age of the people is higher. Now, that doesn't mean that the more computers are causing the average age to be higher. There are some other variables present because usually if there are more computers, then it's probably a wealthy country, a rich country. And if it's a rich country, then there are more medical facilities, and that's resulting in higher age of people or higher lifetime of people. So there are hidden variables present. That's why just because two variables are moving in the same direction doesn't mean that they're causing. So the nutshell is that correlation is not causation. If we find that there's a linear correlation between carbon dioxide in the atmosphere and the global temperature, does that indicate changes in carbon dioxide causes the global temperature to change? So again, we don't have to think of it as what our opinion about this is. Different people can have different opinion. Statistically, as I just said, the statisticians love to say that correlation is not causation. So what they want us to say in this answer, because this is a statistics course, is that no, the presence of linear correlation does not imply that one is causing the other.